A particle located at x equal to 0 at t equal to 0 starts moving, means initial velocity 0, along the positive x-axis with velocity v varies as this. So this is the equation where velocity as a function of x is given. Okay. Then velocity of the particle varies with time. It means we need velocity as a function of time. Okay. So that is the main strategy. First, velocity as a function of displacement is given. So I'll write v as dx dt, alpha dx. So it means dx upon under root x equal to alpha dt. So you integrate it. When the time is 0, particle was at origin, na? At x equal to 0. Na? So as at time t, the particle is at x. Well, so we have to perform this small integration. Okay. So we are going to get, after integrating it, x is equal alpha by 4t square. So here it is displacement as a function of time I am getting. Okay. But again I have to differentiate it because I need velocity as a function of time. Na? So if I differentiate it, dx dt is velocity only. So that 2 will come as coefficient. So alpha by 2 into t. So here you see alpha by 2 is constant only. So velocity directly proportional to t. So out of the 4 options, first option is the correct option.